So starting with another topic, which is Bayes' theorem under the statistical and econometrical series, which is related to the topic of conditional probability under the probability and distribution unit. These are the topics we'll be covering under this. So let's start with conditional probability. See, I have covered this topic in detail in one of my tutorials, and I'll put the link in the description. Just for a revision's sake, the conditional probability basically explains the probability of an event, if there is an event, any event A, based on the occurrence of another event, name it as B. So this is what conditional probability tells, and it is denoted by P. A is to B, and what does that represent? It says that the probability, it expresses the probability of event A when event B has already happened. And we can take an example like conditional probability of A given B is defined as, the formula basically used for this is probability of A is to B, which is equal to probability of A intersection B upon probability of event B. When the probability of event B is greater than 0, means it has to happen. There is a sign of a vertical slash, or we can call it a bar. So whenever it is denoted as PA bar B, that means that it is representing the probability of event A when event B has already happened. So now this Bayes theorem is used to determine this conditional probability of any event only. It is used to find the probability of event based on certain prior knowledge of certain conditions that might be related to that particular event for which we are trying to find the probability. Means we have the knowledge of certain events, related events to this event for which we are trying to find the probability of. So we'll further explain this and we'll further understand this how. So now what is the statement of this theorem? The theorem states that if A1 and A2 are mutually exclusive and exhaustive events, means if one is happening, the other cannot happen simultaneously, and capital B is an event which can occur in combination with this A1 and A2, which are the exclusive and exhaustive events, then the conditional probability for event A1 and event A2, given that event B is there, event B is given, then what is the basic equation among them is probability of A1 bar B, meaning to say probability of event A1 when B is given is equals to probability of event A1 multiplied by probability of B when A1 is given, whole upon probability of event A1 multiplied by probability of B upon A1 plus probability of A2 multiplied by probability of B upon A2. And similarly for probability of event A2, conditional probability of A2 will be find out. So meaning to say that it is simply explaining that if there are two events which are mutually exclusive and exhaustive, and there is a third event which is related to these two events, then what will be the conditional probability of event A when B is given or has already happened, and simultaneously or similarly what will be the conditional probability for event A2 when B is given, which is a related event. So now let's get into the formula part. So the formula says that for any two events A and B, if we want to find out the conditional probability of event A when B is given, the ratio or the formula is probability of B bar A multiplied by probability of event A upon probability of event B, when the probability of event B is never or not equal to 0. Similarly, with the same equation we can find out with a little replacement the conditional probability of event B when A is given. So as you can see in the formula, this is the probability of event A when B is given is equal to the ratio I just explained, where PA and PB are the probabilities of event A and B, and we have already discussed that the probability of event B is never equal to 0, means it is likely to happen, A bar B is the probability of event A when B is given or B happens, and similarly probability of B bar A is the probability of event B when A has happened. Let's now see the proof of this theorem. See, we have already studied conditional probability in detail, and I'll put the link of the video in the description box of this video itself. So we know that for conditional probability, if we want to know the probability of event A when B has already happened or B is given, then the formula is P probability of A intersection B upon probability of event B. Similarly, for event B, if A is given, the formula is probability of B intersection A upon probability of A. As we can see that probability of A intersection B is same as probability of B intersection A, so these can be interchangeable. Now we'll derivate equation number 2. We have named them in equation 1 and equation 2. Let us take equation number 2. So here this can be probability of B intersection A. If we take it on one side, it becomes probability of B when A is given multiplied by probability of A. Now see, as we know these are same, we'll take equation number 1 again and we'll replace probability of A intersection B by probability of B intersection A. So it becomes probability of A when B is given, it becomes, we'll take this value of probability of B intersection A, so it becomes probability of B upon probability of B. So what we did, we replaced this by this and we simply put the derivative value of probability of B intersection A. Let us name as 3. So we've simply put in the value of B intersection A in this form in equation number 1. And this becomes equation number 4, which is nothing else but Bayes' theorem. Now there are certain associated terms. Let's see to them. So the very first is the most common, hypotheses. We generally call them as assumptions. Here it's the event happening in any sample space. Events like E1, E2 or n number of events. They are known as the hypotheses. Then comes the priori probability. Priori probability is the initial probability of an event occurring before any new data is taken into account or any information is taken into account. Probability of any event EI is the priori probability of the hypothesis EI. Then is the posterior probability. What is it? It is the updated probability of an event after considering the new information. So probability of any event EI when A is given is considered as the posterior probability of hypothesis E1. Why? Because A has already happened and we have certain information about it. So in the conclusion, we can only say that Bayes' theorem, which was propounded by Mr. Thomas Bayes, it has made a very complicated subject very simple in the way that it tells the likelihood of an event occurring when there is a probability of another related event is given. So it makes us very easy for us to guess about the world, which is quite unpredictable. Based on any information we already have, so we can just guess the outcome or the likelihood of an event to happen because there is certain information available to us related to it. Hope it could help, and I also hope that the coming year 2025 brings you new learnings, amazing achievement and everything that you've been wishing for. Thank you.